Hello YouTubers! Today we're going to be going through problem 136 in LeetCode, which is single number. Now single number states that given a non-empty array of integers nums, every element appears twice except for one. Find that single one. Here's the real kicker. You must implement a solution with a linear runtime complexity, which is fine, but use only constant extra space. And what does that mean? It means we can't do like an array list or a hash map, because basically the easy way to do this is just assign every value into the hash map and then see if on the next pass see if that value exists and then remove it. So the only thing left would be the number that doesn't have a matching element, but they want you to use constant space, so you can't do that. Anyway, so input nums equals 2, 2, 1, and the output is 1. It's the only element that doesn't have a matching pair. 4, 1, 2, 1, 2. 4 is the only one. Doesn't have a match. And then 1, if there's only one number, we're going to return that number because it doesn't have a matching pair. Alright, so how in the heck are we going to do this? Alright. So we're going to use what's called the XOR, the exclusive OR operator. So what does that mean? So if you have a number 0 and you XOR that with another 0, it returns false. So these are both the same. So it's like, we don't like twinsies or whatever. Same with the 1. This is binary, that's going to return false. But if you have a 1 and a 0, hey, that's okay. Same with 0 and 1, it's also true. For this problem, we're going to be concerned with taking the number. So this would be the number that doesn't have a matching pair. We compare that to 0, and it just returns the number. However, if the number has a match, then it returns 0. So this will zero out all the numbers that have pairs. All right. So this is the method that LeetCode gives us, passing in an int array, and we return the int that is the singular value. First thing we're going to do is define an integer a and make that equal to 0. So this will be our return value here. So this for statement basically says we're going to define an int I, and it's going to basically loop through every value in nums. Just another type of for statement basically. So we're going to make a equal to a XOR I. So for example, if the first number is 4 and a is 0, 0 XOR 4 is just going to be the 4. And it'll go through every number until we get, go through all the numbers, and the only thing left in A should be the one number that doesn't have a match. And then we're just going to return that. And that is the entire method. So let's go through the debugger on this one. Okay, so for this example, I'm just going to start with a simple example. So 1, 1, 2, 2, 4. So if we debug that, rerun it. What the heck? All right, so a is 0. Int I num, so I is equal to 1. And a is equal to 0, I is equal to 1. So a becomes 1. Now we go through this again. A is 1, I is 1. So now a is going to be equal to 0. We do the same thing with the 2. 0 compared with 2, XOR that is going to return the 2. And then we have another 2. XOR that, it's going to get 0, or a will be equal to 0. And then finally we have the 4. 0 and 4, just a is assigned to 4, and then we return 4, and that is the answer. However, I did cheat a little bit because I put these in order, where the 1, next operator, the next element is the 1. Now, obviously that's not the only way they could, the order could be. So I have another example up here, but let's go. I want to explain something real quick. Okay, So the way to look at this, what it's actually doing behind the scenes. So you have, we're taking the first 16 numbers, so 0 and all the way up to 15. What XOR is actually doing is converting each number to binary. And then it's comparing that, those two numbers in binary. But for this example, we don't really need to do that. I mean, we don't need to be concerned with that. And I have another tutorial called binary search add binary that goes through how to read binary. But I think the better way to explain this is to look at it in bits. So decimal 0 equals 0 bits. Decimal 1 equals 1 bit. And 2 equals 2. But 3, because bits are expressed as 1, 2, 4, 8, 16, 32, 64, yada yada. So 3 is expressed as 1 plus 2. And you see like 10 is 8 plus 2. And so on and so forth. So we have 1 plus 2 plus 4 plus 8 for 15. So if you take 2 XOR 3, you see you have 2 here, but then 3 is 1 plus 2. So what happens is the 2's just cancel out. So all you're left with is the 1. So 2 XOR 3 equals 1. Now let's do 2 XOR 5. So 2 is 2 bits and 5 is 1 plus 4. Well, these are all different numbers, so it's going to be 1 plus 4, or 1 plus 2 plus 4, which is 7. So it can be kind of misleading because it looks like it just adds the two numbers together, but it's not really doing that. So let's take 2 mod 10. So 2 is the value 2, and 10 is 2 plus 8. So the 2's cancel out, and you're just left with the 8. So 2 XOR 10 is equal to 8. All right, now with that new information, let's go back to this example, and I'm going to actually bring in that little graph here. Okay, so we're going to comment this out and uncomment this, which is 2, 10, 5, 2, 5. And let's run this and see what happens. Yeah, rerun it. Okay, so the 2 is the first number that it's going to grab. So A is 0, I is 2. And so now A is equal to 2. Now we have the 10. So we're comparing 2 XOR 10. So if we look over here to our cheat chart here, we have 2 and 10. So the 2's cancel out, and you're just left with 8. So now A should be equal to 8, which it is. So now we have 8 and 5. So if A is 8, which is just 8, and then we have the 5, which is 1 plus 4. So we don't have any matching numbers here. So we're just going to add 8 plus 4 plus 1. So it should equal 13. All right, now 13 and 2. So 2 is 2, 13 is 1 plus 4 plus 8. Well, there aren't any matching numbers in there, so we're just going to add 13 plus 2 to get 15. Now we have A equals 15, 1, 2, 4, 8, and I equals 5. Well, I is 1 and 4, so we subtract out the 1 and the 4, and all we're left with is 8 plus 2 for 10. And that is the answer. It's 10 is the only element that doesn't have a match. And so that's really what XOR is doing. But anyway, all you really need to know is that when you compare a number, XOR number against itself, it returns 0, and XOR against 0 returns the number. Okay, so let's run this through LeetCode. Run this, accepted, submit. Ooh, 93, faster than 93.77 submissions. And uses less memory than 89.69. Fantastic, fantastic results. All right, let's go through the space and time complexity. So the time complexity is O of n. We have one for loop. We have to go through each number in the interarray, so there's no way around that. But the space complexity, we have satisfied requirements by LeetCode because there's no extra space needed. We have an integer, and we're just basically XORing all the numbers until we have one number left. And that is it. So thank you again for watching. Let me know if you have any questions or concerns in the comments, and we'll see you next time.